Welcome everyone. Today we are going to learn drawing of profile and geological cross section of this particular map. So our objective is to draw a profile along line XY and draw a cross section along the same line. That is, if we slice out this area along this line, so what we are going to observe along the vertical section in subsurface conditions. We have also to interpret the geological history of this particular area. So let's first understand the map, different elements of the map. So this direction in the map, because the north is not mentioned, so top of the map is always north. So this direction is north, which I am marking with red arrow. And the map scale for this particular map is 1 inches is equals to 1000 feet. Like other maps we have done earlier. So scale is 1 inch is equal to 1000 feet. This is the north. With respect to north, this will be east and west. This will be south direction. Now let's observe the elements of the map. So here we have contour lines. The contour lines are starting from 400 and the maximum value of contour line is 900. So a relief in this area is varying from more than 300 feet to less than 1000 feet. In another word, we can say the minimum relief of the area is more than 300 feet but less than 400 feet, and maximum relief of the area is more than 900 feet but less than 1000 feet. We observe in the southern region we have least relief, and in the northern region the relief is higher. Here it's some valley, the hills are rising like this, and in between we have here we have hill, and in between we have valleys here and here. So we have now explained the topography of the area. The second point, that what are the structures present in the area. So in order to know about the structures, we will have to see the pattern of the beds and relationship of the beds with contours. So here we can see there are some beds, some traces of the beds. So 1, 2 and 3 traces which are almost similar, since they enclose different lithology, so they are of different widths. And if we observe this particular trace, so this trace is somewhat different from this trace, and this trace. If we look carefully, we are finding that these traces, this trace or this trace or this trace, they are abruptly being truncated along this trace. So why any feature abruptly truncates? So this type of abrupt truncation, it gives a point we can go in 3 directions if we take the traces. So this is known as truncation of the beds, and this happens when older sequence meets the surface of unconformity. So these beds or these traces represents some older sequence, and this represents an unconformity, this trace. So if one unconformity is present in the area, this is angular unconformity, that's why traces are truncating over here. So if one unconformity is present in the area, it means there are 2 sequences. So we have presence of unconformity. in the area. So generally, one unconformity separates two sequences, one older sequence and second younger sequence. So older sequence is separated by unconformity from the younger sequence, and older sequences are generally more deformed in comparison to the younger sequence. So here if we see the relationship between the traces of the beds and contours, we can find out that these older sequence beds are dipping in nature because the contour values are intersecting the traces of the beds, and more than one value of contour lines are intersecting a single trace. So it means one trace is present at different heights. That means that these older beds are dipping in nature. Further, if we are going to analyze, then we are going to find out that the strike lines are somewhat closer to each other. That simply means that tips in these areas are somewhat steeper. So take any one of the trace and just draw two strike lines on the trace. So let's choose this one and draw it clearly. So I'm going to take a pen so that it is clearly visible. You will have to draw this exercise by pencil. So just mark the 2 points where these contour lines are intersecting the trace. Just draw it. So here we have drawn one strike line. The value of this strike line is 500. Now in order to know the dip direction and dip amount, we need another strike line with successive higher or lower value. So this one is 500. Now we need either 600 on the same trace or 400 on the same trace. 400 is not intersecting that trace, but 600 is intersecting. So we can draw one more line parallel to the earlier strike line, and that is going to give us the second strike line of value 600. So perpendicular to the strike line there is a true dip. It means the dip is in this direction. True dip is in this direction. Right? Then we have to know that what is the amount of dip along our section line. For that we will have to extend this strike line. So let's extend it up to our section line. So here is a section line. This is 600, this is 500. So we will get HE in this amount. Will be HE. So this will give us the amount of dip as well. Then because this distance is somewhat less, so the beds will be somewhat steeper, we can determine the amount. We will be determining. So let's determine it first, then move for another exercise. So to determine the dip, you need to take HE either out of this map and draw it somewhere, or you can draw 0.1 inches carefully perpendicular to HE, and so this is 0.1 inch, that will be our CI, and join HE and CI. So this is going to give us the amount of dip. We can measure this value. This will be amount of dip for older sequence. So just of the set square and measure the value. So we can see the tip amount is roughly 13 degree. So here mention this tip amount is 13 degree. Now we have to know that what is the inclination of younger sequence. So older sequence contains 3 traces. It means the number of beds are 3 plus 1, that is 4. So here we have 4 beds and we have determined the direction of dip. So younger beds occur in the direction of dip. So opposite to the dip will be oldest bed. So let's mark the beds which are younger and which one are older. So opposite to the dip direction we will get oldest bed and we will mark that with symbol 1. So this is our oldest bed. Then we have bed number 2 in the direction of dip next to the youngest bed. Then we will have bed number 3 of older sequence. We will have bed number 4 of older sequence. Right. So older sequence contains 4 beds. Now we are left with the younger sequence, which is separated by an unconformity. So unconformity in any map is marked by zigzag lines. So whenever you get any map containing unconformity, mark the surface of unconformity with zigzag lines like this. This is again the same unconformity which is exposed over here as well. So this whole surface is surface of unconformity. You have to mark it by zigzag lines. So that represents the surface of unconformity. Now it is visible. Then above the unconformity we have younger sequence. So younger sequence has got 1 trace. It means this has got 2 beds. Now we will mark younger sequence with different symbols. So we are going to use the Roman numerics. So this is first bed of younger sequence and this is second bed of younger sequence. Just above the unconformity we have first bed and then we have second bed. So this will be bed number first and this will be bed number second. So now we have interpreted that in this area there are 2 sequences. One sequence is older, which is consist of 4 beds which are dipping from y to x, and then we have younger sequence which contains 2 beds. Now we are going to determine the dip of the beds as well. that what is the amount of dip of younger beds. So for that we will have to draw two strike lines on a same trace of the younger bed. So we can use either the bedding plane or trace of unconformity. We will have to determine the dip of unconformity, and the bedding planes will be parallel to the unconformity plane for younger sequence. So we need two strike lines which are drawn on plane of unconformity. So here one value of contour line is intersecting, this is 700, and here 800 is intersecting. So one point is here, 800 is again intersecting somewhere here. So this is again one strike line for unconformity plane. Then we need successive higher or lower value of a strike line parallel to the first strike line. The value of this strike line, because this is unconformity plane, it is being intersected by 800, so it will be 800. Now we need either 900 or we need 700 intersecting the unconformity plane, and that strike line will be parallel to this strike line. So let's put a set square over here and take a set square which becomes guiding one in order to move it parallel. So orient it and now move parallel so that you get at least one point where the value of 700 is intersecting the same trace of unconformity. So here we have unconformity which is intersected by 700, and here it is also intersected by 700. So we are going to choose the nearest point. So there we will get another value of a strike line. We'll join these points. So this is our strike line. So we have got this much amount of HE for our unconformity plane. Now we have to determine the dip of this unconformable surface as well, or dip of unconformity. For that we will have to draw a CA equals to 0.1 inch on HE. So either we can measure this distance HE, this is HE, the difference between two strike lines on the section. So we can draw this HE over here, and by joining these points we are going to get the value of HE for unconformable surface. Then if we join it through a line which is drawn perpendicular on it, having length 0.1 inches, so that is our CI. So here is 0.1 inch. By joining these 2 points we will get the amount of dip for unconformable surface. So be careful while joining and measuring these angles. So here we can see that our unconformity is dipping with an amount of 3.5 degrees. So we are roughly going to use 3.5, it is close to 4. So we are going to use 4 degree. So this unconformity plane is dipping with 4 degree amount, and older sequence is dipping with 13 degrees. So older sequence are more deformed, they are steeply dipping, and younger sequence is gently dipping. Now we have got two sequences, older sequence and younger sequence. Younger sequence contains 2 bits and older sequence contains 4 bits. Now the dip direction, this is 800 and this one is 700. So unconformable surface is dipping in this direction from X to Y, but older sequence is dipping from Y to X. Now we know that what are the structures in the area, and we can interpret the geological history as well even before drawing the map. So we know that bed number first must have deposited over unconformable basement, unconformably, followed by conformable deposition of bed number 2, 3 and 4. And the area must have been uplifted, tilted and eroded to form this erosional surface. And after the erosion, there must have been deposition of bed number 1 of the younger sequence unconformably, because this is an unconformity surface, and conformable deposition of bed number 2 of younger sequence. Then the area must have been again uplifted and dipped to 4 degree, so that we are getting 4 degree dip of younger sequence as well, to form this type of landscape. And erosional processes must have exposed these older and younger beds in this area. So now let's draw the profile and cross section of this map. We have already done the exercises relating to the dip and strike value. So our next step is to draw the cross section. So in order to draw the cross section, what we do, either we make a strip or just fold this map. So let's fold this map and draw the baselines. So here is a point Y and here is a point X. So by joining these 2 points, we will get the baseline. Let's draw it. So here is our baseline, and above the baseline we will draw some points having intervals of 0.1 inches, so that they are going to represent the 100 feet height, because contour interval over here is 0.1 inch, and we have contour values ranging from 400 to 900. So it will be sufficient if we draw up to 1000. Now we'll have to mark the 0.1 inch divisions. Up to 1000 over here, and similarly up to 1000 over here as well. So now we will have to mark this. This is a 0 value, this is 100. I'm going to leave 200, then I'm going to mark 300 in this direction, 400, then this will be 500, 600, this will be 700, 800, so this will be 900, and this will be 1000. We are going to draw another values in this direction. So this is 0, this is 100, So here is a 200, this is 300, this will be 400, this is 500, this will be 600, 700, this will be 800, this is 900, so this will be 1000. So now we have drawn this contour values. So now we will have to plot the contour values. So here we are getting one contour 800, and here again 800 is repeating. This is 900, this is 900 back again, and here is 800, and after 800 we are not getting any of the contours. Let's mark these values. I will remove them afterwards, so I'm going to use pencil for it. 800, I'm writing 8 only. This is 900, so 9, 909. This is 700. This is again 800. 700 we are not getting. 800. And after 800, the variations are showing that this value is 700. So here our profile is going to lie between 700 and 800. And in this direction, this is 800 and this is 900. So here between 800 and 900. So we'll have to project these heights in order to draw the profile. So at whatever points we are getting these values, we are going to project it. 800, 800 back again. Then we have 900, here we have again 900, and here we have 800. So this is our 800 point, and this one is 900 point. Let's check it once more. Yes, this is 900. So now by joining it smoothly here, because the variation is between, this is 800 and here is 700, so we'll join it in between 700 and 800. So this is 700 point, this is 800 point. I'm going to tilt a bit in order to draw it accurately. So between 700 and 800, this is 900. Then we have again 900 over here. Then we have 800. Again, and it will go in between 800 and 900. So this is how our profile is gonna look like. Then we have drawn it. Now we have to draw the traces of beds onto the profile. So here we have one trace of the bed, and here we have another trace of the bed. So we are going to project it onto our profile. So here one bed, and here we have second bed. We are not getting older sequence onto our section line. So how we are going to get it? Because we know if there is no erosion, the beds always stretch in the direction of their strike. So if we have to plot these beds, we will have to stretch it onto the section line along the direction of their strike. So this is the rule. We are going to stretch the beds. So I'm going to use some pen so that visibility is clear. So in order to stretch it, because this is the strike of the older beds, so these traces are up to here on unconformity, we have to stretch them onto our profile line or section line. So this will come like this. Similarly, this line parallel to this particular strike line will come somewhere here, and similarly the third trace will also come like this. So that's how we are going to get our these older beds onto the section line. So now we will mark them as well. So now we have got one more bed somewhere here, another bed here, and one more bed over here. So first what we do, we draw the surface of unconformity, and after drawing the surface of unconformity, we can see that this dip of unconformable surface is from x to y with an amount of 4 degrees. So in order to draw it, we need to draw guiding angle of 4 degrees onto our baseline. Just put a point and draw a 4 degree angle. So here is a 4 degree. Join these points. And now our unconformity will be dipping parallel to this 4 degree angle. So just in order to draw it parallel, what we need to do is to keep a protector like this and put another protector as scale so that it becomes the guiding line. So here is our 4 degree line, and I have put a scale in order to move this protector parallel to this line. So here we have one trace, and here we have another trace. But before that, we have trace of unconformity as well. So this particular trace we can see here is trace of unconformity. So we are going to draw the trace of unconformity first. Should be parallel to this angle. So this is our trace of unconformity, and parallel to this we'll have another bed here. Now our beds are below the trace of unconformity, so we should project them over here onto the trace of unconformity. So we are going to mark the unconformity with zigzag line. And then we are going to draw our older sequence of beds. So we have got two beds, first bed of older sequence and second bed of older sequence, and our old first bed of younger sequence or second bed of older sequence. But now we need to draw our older sequence below this younger sequence. So what is the direction and amount of dip of older sequence? So this is 13 degree, we have already determined over here. The dip amount is 13 degree and dip direction is from y to x. So we will have to draw a line for an angle of 13 degree. So here we are taking one point, guiding point, in order to draw a 13-degree angle from y to x. So this direction is x direction, this is y direction. Now draw 13-degree angle. Join these 2 points, you will get a 13-degree angle. Now our older beds will plot parallel to this line. So where are our older beds? One is here, so we'll project onto the unconformity. Another here, we'll project onto the unconformity, and here we are again going to project it over here. So these 3 beds are going to plot parallel to this 13-degree angle. Now orient a protector, keep a scale parallel to it, and draw these beds. From these points. Now we need to fill our symbols. Of these beds. So if we start walking, then we get these beds above the unconformity, and we get our 4 beds up to here below the unconformity. So now let's fill out the symbols. The bed number 1 of unconformity is filled by yellow color symbol over here. So this is our first bed above the unconformity. This is younger sequence first bed, and the second bed is not colored, rather it has been given a symbol. Like this, so we will fill that symbol as well. Now we are supposed to make this profile somewhat darker, so I'm going to draw it dark line. So this is our profile. Now we are going to fill the symbols. This is how the symbols are there for our second bed of finger sequence. Then we need to fill the symbols for our first bed's younger sequence. So younger sequence is represented by the first bed in younger sequence is green in color, so we are going to make it green. But before that we will have to fill the symbol. So it is represented by parallel lines. and then followed by green coloration. So this is first bed of our folder sequence. Then second bed is represented by coarse dots and then red colors. So here is our second bed. This is occurring in subsurface like this. And then we have third bed, which is represented by triangular dots and cream blue color in them. So fill this color as well. Now we have fourth bed, which are represented by this particular color, and before that we have fine denser dots. So here, so we are going to draw it. So this is how our section is going to look like if we slice out the area along line XY. Here is the surface of unconformity. Above the unconformity we have younger sequence, and below the unconformity we have older sequence. We have 2 beds in the younger sequence and we have 4 beds in the older sequence. So these are those bits. So this is X and this is Y. At baseline they are represented as XY like this. So this is the map. If we slice out this map along XY, this is how the profile is going to look like, and this is how the cross section is going to look like. Now we have drawn the cross section, and within the subsurface beds are going to appear like this. So suppose you get an idea that there are oil deposits or gas deposits which are present over here, then how you are going to drill it to get it. So for that you need the cross section of this particular area so that you drill at exact point and get the same beds. Let's say this is the ore deposit bed. So how you are going to get it? By exposure only, because this will not give any idea that how the beds are going deeper into the ground. So you need to dig out only this portion. So in order to do that you need cross sections. So you prepare the cross section with the help of a structural data and surface data. So this is our cross section or geological cross section. along line XY. So our exercise is now done. Now we need to interpret this particular map, and we interpret the map within 4 points. So what are those points? Those 4 points are, in fact, first point is topography, our second point is structure, third point is order of superposition, and fourth is geological history. So topography, we can see that the relief is varying from 400 to 900. So we can easily say, because we are getting the contours of 400 and contour of 900, not more than 900, not less than 400. So our minimum relief of the area is more than 300 feet but less than 400 feet, and the maximum relief of the area is more than 900 feet less than 1000 feet. So topography is fine. Then we discuss the structures. So in the structures, in this particular map, we have two sequences, older and younger sequence, and they are separated by unconformity. And unconformity, this is an angular unconformity. Older sequences consist of 4 beds and younger sequences consist of 2 beds. So we have 4 older beds, 1 angular unconformity and 2 younger beds. So these are the structures. Order of superposition. So we draw it in undeformed manner in order to know the order of sequence or order of superposition. So at the base we have bed number 1, which is again on an unconformable basement because the lower surface of bed number 1 is unknown. Then we have bed number 2 of the older sequence, then we have bed number 3 of the older sequence, then we have bed number 4 of the older sequence. This upper surface of the bed number 4 is represented by an unconformity. Then we have bed number 1st and bed number 2nd. For our younger sequence, we have to fill the symbol over here as well. So the first is represented by a green symbol, but before that we have these type of lines and we fill the green color. The second bed is represented by coarse dots, and red color. Third bed is represented by triangular dots and blue color. The fourth bed of older sequence is represented by fine denser dots and the brown color in them. Then we have first bed of younger sequence, again represented by coarser dots and yellow color. And then finally we have the youngest bed in this particular area, that is our bed number 1st. It is represented by this symbol. So this is our order of superposition. Now geological history. the bed number first, yani bed number 1 of older sequence must have been deposited unconformably over an unknown basement like this. Then conformable deposition of bed 2, 3 and bed number 4. So this is 1, 2, 3 and 4. Then the area must have been uplifted and tilted. So uplifted and eroded to form the unconformity surface. Then after unconformity, the bed must have been tilted a bit. So there is a deposition at 4° angle. So the sequence has been deposited like this. This is bed number 1, 2, 3 and 4. And here the deposition must have been occurred after the erosion of these beds, bed number 1 and 2. Then because they are dipping 4° in this direction, so the area must have been rotated by 4° in this direction. So earlier dips must have been 13 minus 4, that is 9°. Then after this rotation, these older beds have been dipped to 13° and the younger beds have been dipped to 4°. Then there must have been erosion in the area to form the present day landscape. So thank you. Today we have learned the map containing an angular unconformity. So 2 sequences, and this is the map. For the map we have got a cross section like this. In the next classes we will be learning the maps containing some more structures.